session, we will going to discuss about types of beams, my dear students. It's a very, very important question, my dear students. For external examinations, this question is very, very important, my dear student. I have to concentrate here. So, just 5 minutes. Okay. Now here, types of beams. Types of beams, my dear students. Types of beams. There are 2 types of beams, my dear students. The first one is statically determinate beam, my dear student. Statically determinate beam. Statically determinate beam, my dear students. Next, number 2 is statically indeterminate beams. Indeterminate beams. Statically determinate beams, statically indeterminate beams, my dear students. So, now, here, statically determinate beam. So, you know equilibrium equations. Just now we have discussed. That is already studied in engineering mechanics. Number of equilibrium equations? 3. Okay? That is, we are always talking about 2-dimensional system. So that motion is prevented in x direction. One reaction, that is sigma fx is equals to 0. Motion is prevented in y direction. Sigma fy is equals to 0. Motion is prevented, momentum. Motion is rotation is prevented about z axis direction. Sigma moment is equals to 0. These are 3 equilibrium equations, my dear students. Now, so first of all, we will discuss about the statically determinate beam. It is a very simple here. It is a very simple. You concentrate only just 5 minutes here. So here is first of all statically determinate beam. Statically determinate beam, my dear students. Statically determinate beams. So first of all, here number of reactions are less than or equals to number of equilibrium equations. Number of equilibrium equations. Number of equilibrium equations, my dear students. When number of reactions are less than or equals to number of equilibrium equations, all such type of beams are called as statically determinate beam, my dear students. First of all, so under this, so first of all, cantilever beam, my dear students. So cantilever beam, my dear students. What is a cantilever beam, my dear students? One end of the beam is fixed. A beam having one end is fixed, other end is free. Such a type of beam is called as a cantilever beam, my dear students. See, so just now we already discussed types of supports. Here is a fixed support. Here is a fixed support. Number of reactions. Motion is this is a point. Motion is prevented in x-axis direction. This is RAX. Motion is prevented in y-axis direction. This is RAY. Rotation is prevented about z-axis direction. That is MAZ. Yes. So number of reactions 3. Number of equilibrium equations 3. It is a 2-dimensional only, my dear students. So number of reactions 3. Number of equilibrium equations 3. 3 is equals to 3. So this one satisfies this equation. 3 is equals to 3. So that this beam is a statically determinate beam, my dear students. Yes or no? Are you clear? Number of reactions 3 are. Number of equilibrium equations 3. 3 is equals to 3. So that this beam is a statically determinate beam. Yes, my dear students. Now coming to simply supported beam, my dear students. Simply supported beam. Simply supported beam. Simply supported beam. What is a simply supported beam, my dear students? Now, a beam having supports at the end points. At the end points, suppose here is a support. There is a hinge support here. There is a roller support here. There is a roller support here. A beam having supports at end points. Such a type of beam is called as a simply supported beam, my dear student. See, it is a hinge support now. This is A point. This is B point. This is a hinge support. Yes or no? How many reactions just now discussed about that one? So, how many reactions? So that 2 reactions. Motion is prevented in x-axis direction. That is RAX. Motion is prevented in y-axis direction. That is RAY. Now, this is 2 reactions here. But rotation cannot prevent it. See here, for this roller support, only 1 reaction. That is RBY. How many number of reactions, my dear students? 1, 2, 3. So, number of reactions is equals to, number of reactions is equals to 3. Number of equilibrium equations is equals to, equilibrium equations. Number of equilibrium equations is equals to 3. So, 3 is equals to 3. Yes, this condition is satisfied. So, this beam is a statically determinate beam, my dear students. Yes or no? All of you clear or not? Yes. This is about the simply supported beam. Now coming to overhanging beam. So, the third one is overhanging beam, my dear students. All of you clear? Yes. It's a very simple here. So, here is overhanging beam. Third one is, that is C, overhanging beam. Overhanging beam, my dear students. So, a beam having supports not at end points, some distance away from the end points. Such a type of beam is called as overhanging beam. Suppose, see here, suppose if it is a beam, there is a hinge support here, roller support, there is a hinge support is here. So, here is, this support is some distance away from this end point. So, this type of beam is called as single side overhanging beam. Single side overhanging beam. Because only overhanging one side. Suppose here there is another beam. There is another beam. But 2 supports are, there is a one support here. There is another support here. The 2 supports are away from the end points. This is double overhanging beam, my dear students. It is a single overhanging beam. It is a single overhanging beam. It is a single overhanging beam. It is a double overhanging beam. Double overhanging beam, my dear students. But same reactions. Here is a roller support. See, my dear student, here it is a roller support. One reaction. This is A point. This is B point. This is so RAY. So here is this is RBY. There is a reaction like this because it is about 2 reactions. RBX. Number of reactions is equals to 3. Yes. Number of reactions is equals to 3. Number of equilibrium equations is equals to 3. So that number of reactions are equals to number of equilibrium equations. So this type of beam is called as statically determinate beam, my dear students. Statically determinate beam. Now coming to here also same. Here is a roller support. This is RAY. This is a hinge support. This is A point. This is B point. This is RBY. So this is RBX. Here also number of reactions is equals to 3. So number of equilibrium equations also 3. So that it is also statically determinate beam, my dear students. All of you clear? It is about statically determinate beam, my dear students.